And now if we continue talking about resistance, after we talk about Ohm's law, what is the meaning of resistance is not in our syllabus, but as we know that it's the opposite of flow of charges. So that means whenever there is more resistance, that means there is less charge can flow, less current. So the opposite of flowing charges and current. So it's not a definition, okay? Charges and current, electric currents. Okay, it's not included in our syllabus. So the resistance of any conductor depends on several things. Okay, if we're talking about conductors, insulators, semiconductors, okay, all these materials, okay, they have same categories in action for in general, okay, but some of them they have different categories, different things that the resistance depends on. Okay, for example, the length. Okay, what that means, the length is directly proportional to the resistance. What that means? Yes, exactly, directly proportional. That means if the length is increased to its doubled, okay, the value of it, that means the resistance, it will be increased by double. Yeah, for example, if the length increases multiplied by 2, okay, that means the resistance will increase multiplied by 2. If the length is decreased divided by 3, that means the resistance will be decreased divided by what? Divided by 3, and etc. Okay, so that means as the length increases for any wire, the resistance will increase. As the length is doubled, the resistance is doubled for same material. We didn't change anything, the same cross-section area, the same material, only we change the length of the material. Another thing, that the cross-section area, as you can see here, the resistance is inversely proportional with the area. And we know that the area, okay, it's pi r squared. That means, okay, from this, that means the resistance is inversely proportional with the radius square or the diameter square. So this is the relationship between inversely proportional between the resistance and the area. If we put 1 over area, it would be something like directly proportional. What that means? That means if the area, the cross-section area is increased multiplied by 2, the resistance of the wire, if the wire is, the cross-section area is doubled, is thicker, okay, that means the resistance will be reduced divided by how much? Divided by 2. But if the cross-section area is reduced, for example, divided by 3, okay, that means the resistance of the wire, it will what? Increased, okay, because it becomes thinner, multiplied by how much? By 3. But if we said about radius or diameter, if the radius is increased multiplied by 2, because there is a square here, that means the resistance will what? Will decrease divided by 2 square to the power of 2. Why square? Because we know that the area is pi r squared. So as the radius or the diameter is doubled, the area increased by double square 4 times. So as the that means as the area increased by 4 times, the resistance will what? Reduce by 2 what? Square, which is 4. And on the other hand, if we are talking about the diameter, if the diameter is reduced divided by, for example, 3, that means the resistance of this wire, okay, will increase multiplied by what? By 3 square, which is how much? Which is 9. Okay, so first factor, it's the length. Second factor is the cross-section area. Third factor is the temperature. As we said, it's not in details included in our syllabus, but generally for metals, as temperature increases, the resistance what? Increases. For non-metals and semiconductors, okay, for non-metals and semiconductors, as the temperature increases, the resistance decreases. Now, there is no fact relationship. There is a relationship, but not included in what? In our syllabus. Now, from 1 and 2, we know that we can put them together. Now, we know that resistance is directly proportional to the length and inversely proportional to the cross-section area from 1 and 2. That means to remove this sign and we put an equal sign. So that means R equal constant multiplied by what? Multiplied by the length divided by the what? Area. This constant is a constant value, depends on the material itself. They call it what? Resistivity. It's not included in our syllabus. So that means the resistance equal resistivity times length over area. هلا واحد بيجي بيسالني استاذ طب ليه بتعطينا هاي الفورمولا وهي مش مطلوب منها بالسيلبس. No, I'm talking about this formula, this relationship. Now if I want to make rho as a subject of the formula, which is now in our syllabus, look here, okay, rho, okay, it's equal RA over L. I make it as a subject of the formula. Resistance of the wire multiplied by the cross-section area of the wire divided by the length of the wire. Now rho, it's a constant value for each material. For copper, in everywhere in the world, it's the same value. It's for aluminum, for steel, whatever, okay? So in our questions, usually they ask about this part of the equation, RA over length, okay? So that means R for the first wire multiplied by cross-section area for the first wire divided by the length of the first wire is equal R2, A2, okay, cross resistance for the second wire, cross-section area of the second wire divided by length of the second wire if we are talking about same material, same resistivity, same rho, okay, same material. So this is the formula that we are going to use it if they ask about some of the materials, they change the diameter of it, some of the resistance, they change the diameter, they change the length, something like this. They change the dimensions, but not the same material. Other times they don't ask about this equation because they give us not area, they give us a radius or diameter. So the formula which will be the resistance for the first wire multiplied by the radius of the first wire square divided by the length of the first wire equal the resistance of the second wire multiplied by the radius of the second wire divided by what? The length of what? Of the second wire. Now usually, okay, they ask questions about this formula more than for this formula. طيب أستاذ أنا مش عم بفهم شو دخل هاي الفورمولا. Now we are going to answer some questions about this formula, how we are going to use it from the past paper, and you will see how we are going to use it. خلينا نبلش هيك example from my own. Okay, question number 4. What do we have? Two conductors A and B are made by same material, same element, okay, same wire, but different area, or same conductor, okay? The length of A is twice the length of B. So we have two wires, wire A, wire B. We are talking about area, okay? So the length of A, I'm sorry, this is A and this is B, okay? For first thing, we are talking about the length here. Okay, so the length, okay, for A is twice the length for B, so here 2L and here L, okay. The cross-section area for A is 1/3 of the cross-section area for B, so the cross-section area here, it's area divided by 3, while here it's A. And the resistance, okay, for A, it's 120. How much is the resistance for what? For wire B. Now, as you can see, because they are talking about length with area, so we are going to use this one, the original formula. As you can see, we are going to use it, okay? خلينا نحط ايش values are A, cross-section area of A over length of A, okay, equal RB, okay, area of B multiplied by, divided by the length of what? Of B. Now, if we use this table that we just put the information that we have it, which is twice and 1/3, okay? So RA, which is 120, multiplied by the cross-section area of A, which is A over 3, over the length of A, which is twice L, equal RB, the unknown that we want to find it out, multiplied by the area, which is A, divided by the length, which is what? N. Now we can do what? We can do cancellation. We can cancel A with A and L with L. What's left here? As you can see here, it's 120 multiplied by 1 over 3, and that means over divided by 3, multiplied by 2 equal what? R. So that means R, the resistance, equal, if you use a calculator, it will be 120 divided by 6, which is what? 20 ohms. نعيد مرة ثانية. They give us, we put the table between two wires, wire A and wire B, the length, the area, and the resistance. They said that we are talking about same material. The length of A is twice the length of B. So if this is L, this is 2L. And the cross-section area of A is 1/3 the cross-section area of B. So if this is BA, the cross-section area of B is A. That means the cross-section area of A, it's A over 3. And the resistance of A, it's 120. Okay, find the resistance of B. we use the formula, we substitute, and we cancel the similar value. We use the calculator, or we do cross multiplication. It depends on the math. It doesn't matter how are you doing in math, but it's important to make it correct. Okay, and this is the final answer. Let's go to see past papers from other years. Okay, now this question from May, June 2018, variant 41. Okay, if we go to see the paper, okay, I think question number 8 or 9. Let's go on. Yes, it's this question 7. Okay, what they said: state in terms of their structure why metals are good conductor for electricity, because they have many free electrons and their molecules are close to each other. Many free electrons they have. Many free what? Electrons they have. Okay, now a cylindrical metal of wire W1 of length L and cross-section area of A, okay, has a resistance of 16. A second cylindrical wire W2. So we have W1, wire 1, and W2, wire 2, or cylindrical wire, okay? And they say that the length is L, the cross-section area is A, and the resistance is how much? 16, okay? Now, having wire 2 have a length of half L, so L divided by 2, and the cross-section area of 2A, okay, and it's made by same metal, same material, okay? Determine the resistance of L2. They ask about this value. Now, according to that, what we're going to do? We're going to use the same formula. What is the formula? We are going to use the same formula that we just wrote it before, which is R1 A1 over L1 equal R2 A2 over what? L2. R1, which is 16, shukran, yes, times A1, which is A, divided by L1, which is L, equal R2, R2, which is the unknown resistance that we want to find it out, multiply by A2, which is twice A, divided by what? The length, which is what? L over 2. By doing some simple math, we can cancel A with A and L with L. Okay, what we will get here? Okay, we'll find some values that it will be 16 equal R multiplied by 2 divided by half. When we do that, okay, divide by 2, divide by half, that means multiply by 4. So divide by 4, R will be equal what? 4.0 ohms. Okay, then what they ask? The effective resistance of R1 and R2 connected in what? In parallel, that we studied before. So we know that in parallel, that means we will add them together, multiply them, then divide by their addition. So R in parallel equal R1 times R2 divided by R1 plus R what? 2. Okay, R1, which is 16 times R2, which is 4, divided by R1, which is 16 plus R2, which is what? 4. So, and our answer will be 16 multiplied by 4 divided by 20. It will be 3.2 ohms. Okay, we are not going to answer the rest of the questions, but we are going to see the same topic on another year. Okay, let's go to this year. Only we are going to answer part A of question number 8, and this year is October-November 2013, variant 32. Question number 8, what they ask here in this question. Okay, a piece of wire has a resistance of 0.45 ohm. Calculate the resistance of another piece of wire from the same material with a third of length and half cross-section area. So we have wire 1, wire 2. Okay, we have what? Length, area, resistance. The length for the first wire is L and the area is A and the resistance is 0.45. Okay, the length here is L divided by 3 and the cross-section area is A divided by what? 2. What will be what? the new resistance, we are going to use the same formula, which is what? R1 A1 over L1 equal R2 A2 over what? L2. So we'll put the values that we have it here. R1, which is 0.45 times A1, which is A, divided by L1, which is L, okay, equal R2, the unknown that we want to find it out, multiply by the area, which is area divided by 2, divide by L, divide by 3. By doing that, okay, and we'll use the same math, okay, simple math. We can cancel L with L, A with A. What we will find out here, okay, we'll find out that 0.45 is equal to R multiplied by 3, okay, we move the 3, okay, to the top, okay, divided by 2. By doing cross multiplication, it will be 0.30, okay. What we did here, R equal 2 multiplied by 0.45 divided by what? 3, and this is the answer, and don't forget the unit, which is ohm. Okay, we're not going to answer the rest of the question. Let's go on to another here, to another idea. Okay, the whole question here talk about most of the questions talk about the relationship, okay, about what we are talking, what we study now. This is question number 9 from October, November 2013. Question number 9. What this is? Okay, first of all, state the relationship. Only state the relationship between the resistance R and the length of what constant cross-section area. We can say R is directly proportional to what? To L. The relationship between R and the cross-section area, it's easy. R, it's inversely proportional with what? You can say directly proportional and inversely proportional as words. You can write directly proportional, and here you can write inversely proportional. Okay, type. Now, what they ask here, a 60-watt filament lamp connected to 230 volt. Okay, so that's it. What they ask about the current, and we know that P equal IV, very important person, as we learned before. So the power, which is 60, equal the current that we want to find it out, multiplied by the voltage, which is 230, divided by 230, divided by 230, 6 divided by 230. It will be what? 0.26 watt ampere. Now that's for part B. For part C, again, they ask a question about what we are studying. Okay, what they ask here, look here, focus. Okay, the lamp, okay, lamp Y has a filament made by same material as lamp X. We study lamp X. Now they are talking about lamp Y. Okay, so we have X, we have Y. Okay, the filament has, okay, this filament Y has a length, okay, has a length of half the length of and 1/3 of the cross-section of filament X. So if this is the information that it's LA, and here it's half the length, L divided by 2, and here half, 1/3 cross-section area, okay. They ask about calculate, and this have the same voltage, okay. Calculate the ratio between current and current. We didn't study the relationship between current and current, or we do? We don't, okay. But look here, we know that R is inversely proportional to what? To I. So because they ask about what? They ask about I for Y divided by I for X. That means they are asking for what? They are asking for resistance for X over resistance of whom? Of Y. That's what they ask for. So what we need to do, we need to find the ratio between the resistance, and after that we will find that. We find the relationship between current with current. So we know that, okay, we know that. Let's change the color. We know that Rx AX over Lx is equal to Ry AY divided by what? Ly. So Rx, okay, we will need to put Rx over Ry. So we will do Rx over Ry, okay, and we'll move this. Let me change the color. We will do cross multiplication. We'll move this part here. we will move, okay, this part of the resistance as a cross-section area to here, and we will switch this this length to the other side like this here. We can do cross multiplication, partial cross multiplication, not a whole cross multiplication, and you will find out that we are talking about Lx ay, Lx, I put it here, multiplied by Ly over what? Ly multiplied by what? Ax. And let's put the values that we have it. Lx, which is L, and Ax, which is A, over Ay, which is A over 3, okay, and Ly, it's L over 2. By canceling L with L and A with A, we will find that 1 over 3 divided by 1 over 2, so our ratio is 2 over 3, or you can write it to 0.667 or 67, okay? Allah Akbar, Allah Akbar, al-Izzatu. Okay, good. Hello. Okay, last question, question number 9 from May, June 2014. What the question is asking, okay? Okay, now let's see the question, the part B and C, they ask about what we learn now, okay? What they ask here. If the circuit shows the resistance can be connected between the terminals P and Q, P and Q. The EMF, okay, the voltage is 6 volts for the battery. Calculate the current shown, okay, in the emitter when 12 volt and 12 ohm and 4 ohm are connected in series or are connected in parallel, okay? Now, let's do it fast, okay? Now, we know that, first of all, we have to find the R in parallel or the R in what? In series, sorry, the R in parallel here and the R in series here, okay? So R in series, that we add them together, 12 plus 4, which is equal to how much? Which is equal to 16. So they ask about the current. So the second step, okay, what we will do, we know that V equal IR. So I equal V over R, the current in the whole circuit, the combined for the resistance in series. So which is equal 6 divided by 16. So 6 divided by 16 by using the calculator is 0.375 ampere, okay? Next part of the question, we will do the same thing, okay? First of all, we find the R in parallel, which is 12 times 4 divided by 12 plus 4, and 12 times 4 equal divided by 16, which is equal to 3, okay, 3 ohms. This is the first step. Second step, we will say that I equal V divided by R in series, which is what? 6 divided by 3, and the answer will be 3.0 watt ampere. That's first part AI. Part and double I. Part B, state the relationship between the resistance and the length. We just mentioned it. What's the relationship? It's directly proportional. Proportional. Okay, state the relationship between R and A. It's inversely proportional. Inversely proportional. Okay. Then what they ask, okay, they ask about the ratio between what and what? Okay, they ask if the 12 ohm and the 4 ohm, they are made by same wire, so, okay, of the same length and made by same alloy, okay? So same length and same alloy. Calculate the what cross-section area over cross-section area. So their question is cross-section area for the first wire over cross-section area of what? Of the second wire. So we have the first wire, we have the second wire, and they say they have the A length L over resistance. Okay, the length is the same, or LL. Okay, tamam. The cross-section area we need to find how much is the ratio between both of them. Okay, and what they give us the resistance. The first one, it's 12, and the second one is what? It's 4. Okay, So what do we have? We have to use the formula R1, which is X, A1, which is X, divided by L1, okay, equal R2, A2, divided by what? Divided by L2. L with L, they cancel out each other. So what's left here? We will put that the resistance here, which is 12 multiplied by A, area for 12, equal 4 multiplied by what? Area for 4. And they ask about this one, area 1, over area what? 2. So if I divide area 1 over area 2, it will be equal 4 over what? 12. 4 over what? 12. So the ratio is how much? 1 over what? 3. 4 over 12. It's 1 over what? 3. And that's it about this topic. Okay, if you have any questions similar to this, please send it to me. If you have any question now, send it on the chat. Okay, I'm waiting for your response.